Guys, welcome once more to our YouTube channel. For those of you who are taking physics on Thursday GCE 2023 session, wish you all the best. Be you go rocket. So let's have a quick look at Northwest Mock 2021 as part of your revision process. Okay, let's go. Okay, guys. So again, just pause the video, right? Read the question and check out if you can solve it. All right, let's go. Okay, so this is the first part of the question, right? So let's start with this first part first, the projectile part. So at what speed should a basketball player project the ball from a height of 2.1 meters above the ground? So you can just go ahead and read the problem. So this is really what is happening. So you're projecting the ball 2.1 meters above this ground, and then you notice that the net itself is 3 meters above the ground. So if I project the ball and it goes through the net, hey, what is the vertical distance the ball has covered from this point, this plane of projection? It would simply be what? 3 meters, right? Minus 2.1, because the ball was not projected from the ground here, it was projected from this side. So its vertical displacement is basically this tiny portion like that, which is 3 minus 2.1. So you have 0.9 there for the vertical displacement. And then remember that this net is 5 meters away from this point of projection. So the horizontal displacement of the projectile particle at this instant when it goes through the net is 5. So if you know these basic things, very crucial, you now notice that we have been able to define a coordinate along the path or along the trajectory of the projected particle, and that is crucial. So it tells us that we are going to use the equation of path of that particle, okay? The cartesian equation of path. So y equals x tan theta minus gx squared sec squared theta over 2u squared. This is the equation of path of any projectile. So be it in physics or mass mechanics, you use this, okay? So, and whenever you have these x and y coordinates, don't think twice. Even in mass mechanics, don't think twice. Go directly to equation of path, okay? Sometimes they'll ask you that prove that this point like that lies along the path of the projectile. Hey, just pick that point, put it in there, and see if it gives you the other values that are described in the question. If it does, boom, it lies. Okay, so let's make u the subject because we are looking for the speed at which you project, right? So this is the equation, make u here the subject. That's from 3 work, right? So put in the thing you have to put in. So theta there is 38 degrees. Sec theta, of course, which is sec square theta is the same as 1 plus tan square theta, so it gives us 1.61. Square that and then put every other thing in place, right? So 2u squared will be this. So our u there will be approximately 10 meters per second. Okay, technically 10.3, but again, you're respecting the number of significant figures of the list of the data with the least significant figures that it's given to you in the question. Okay, this is one. So we go ahead and then we talk about calculating, determine the maximum height above the ground which the ball attains. So again, we can deduce what the maximum height would be, because at the maximum height, Vy is 0, right? So let's use this equation of motion. Vy squared equals Uy squared plus 2gs. Vy is 0, so get the Ui here. The particle is going upwards, going against gravity, so g is negative there. We have negative 2gh, so s is h, right? So h there will be Ui squared over 2g. So h is Ui. What is Ui? It's u sine theta, right? Excuse me, guys. So you have 10.3 there sine 38 squared divided by, because our u here is 10 now. Remember that this is just the answer that you give the examiner so that it ties with the number of significant figures. I've always told the students, always make sure your answer is in 2 significant figures. Any physics problem you're answering in the GCE, always make sure your answer is in 2 significant figures. This one is in 1, it's okay. But in the exams, I would prefer that you always write your answer in 2 significant figures. It does not matter what the question is, writing in 2 significant figures is always going to be correct. All right, the number of significant figures will always be correct. Okay, so you notice that our h there is that. So what is that? It's 2.1 meters. So that's the maximum height reached by our particle, projected particle. Okay. So the other part says that describe the suitable experiment which can, okay, guys, so you check out the experiments, okay? So C says a piece of metal of mass that, specific capacity that, at a temperature that is dropping to, okay, this is an easy peasy problem. So that's our data, the mass of the metal, specific capacity of the metal, initial temperature of the metal, mass of the calorimeter. And then notice that we're talking about initial temperature of calorimeter and its content. That's why you see double C here, 23 degrees Celsius, because the moment the examiner gives the mass of the calorimeter, hey, it means that that initial temperature there is the equilibrium temperature between the calorimeter and its content. Okay, so now heat loss by the metal, of course, has to be equal to heat gain by the calorimeter and water. So heat loss by the metal is mc delta theta of the metal. Okay, heat gained by the calorimeter is of course mc delta theta of calorimeter plus mc delta theta of water. But since delta theta is the same for both of them, okay, because they're always in thermal equilibrium, you notice that I can factor that out and then put it like that. So again, m of metal, c of metal will give us 9.6 there, right? So we can just simplify, and then yeah, I'm just really doing some nice simplifications here. So change the temperature of the metal is 185 minus theta final. Change the temperature of the calorimeter at its content is theta final minus 53. Okay, so that gives us this. So again, we can make theta final the subject from this particular expression. You notice that there's our theta final, and our theta final is 26 degrees Celsius. So I've not put the degree Celsius.